Today we're going to be looking at arc length and sector area in more depth. We will start off by looking at their formulas, keeping in mind what we've established before, that 360 degrees and 2 pi radians are equal to each other. They are both a full circle. We will first convert these arc length formulas, which are currently in degrees in orange and green, to their radian counterparts. They are both equally useful. It just depends on what the problem has set up with originally. Whether they're giving you an angle in degrees or radians would tell you which formula you are going to be using. Your other option would be to convert whatever they give you in angle measurement to the form or the units that you're more comfortable with, depending on the problem you're working on. So let's convert these degrees formulas to radians first, and then we'll get to some examples afterwards. Now for arc length, we need to replace the 360 right here. We're going to replace that with 2 pi because we know that they are equal to each other. That would make the formula, theta, or the unknown angle, divided by 2 pi, would then be multiplied by the same thing, 2 pi r. And now that if we kind of look at this fraction, we can think about, well, I have a 2 pi in the numerator over here, since this is kind of like it's over 1, and 2 pi in the denominator, so both of those are actually going to cancel out. And that means the only thing I have left over to use is the theta for the unknown angle, and then r for the radius, which means that to find arc length using radians, all you have to do is your angle in radians multiplied by your radius, and that gives you the arc length of any arc. And that, remember, that's the purple thing over in this circle to our left here. Any angle made in the circle here, where your angle right here is theta, that would hit an arc, and that's how you find how long the arc is if you have your radius lengths on the side. Now for sector area is a little bit different, but a lot of similarities. We're still going to replace that 360 first with a 2 pi. So we have theta over 2 pi. And that would be the first parentheses. And in the second parentheses, we still have pi r squared as our first part. And then we are going to just have that be over 1 since it's not a fraction yet. Now, if we look at our formulas here, we now have a 2 pi in the denominator and pi in the numerator, so we can cross off those pi values. And that means that our formula in the radians version would end up being a theta over 2, or half of our angle in radians, being multiplied by our radius squared. So if we want to put a label on both of these, all of these, this formula up here and this formula up here are the radians version. And the formulas we started with right here and right here are going to be the degree versions of those same formulas. So we gave and write degrees there, but we kind of already covered that. So now in our next part of this video, we'll be looking at some quick examples of finding the arc length and sector areas in specific problems. In example number 1 for finding arc length, we have a central angle of 120 degrees that we can mark with theta, and we have our radius length of 6 that we can mark with r. So we're going to use our formula to find the arc length of arc x, which we can label with the same color. We're looking for this arc length right here. And we will do that by doing 120 over 360 in parentheses for the angle part, and then multiply by that. The whole circumference would be 2 pi times the radius of 6. And that ends up equaling approximately 12.6 round to the nearest tenth. Moving on to the problem to the right, we're going to ignore stating the answer in terms of pi for now, but we have an angle of 160 and a diameter of 4 inches. So that means that we could take half of that diameter and make it a radius length being equal to 2 inches. And so let's find the answer for arc length that we're finding. In this case, we are finding the arc length from A to B going this direction because that's what the central angle of 160 is hitting. And we would do 160 divided by 360, almost half of the circle. And we would then multiply that by the circumference of 2 pi times 2. And if you put all of that into your calculator, you get approximately 5.6 inches for arc A to B in this problem. We are now looking at some sector area problems. In the first example, we are looking for this green sector. And so we want to use our sector area formula, given that we have 60 as our theta and r is 4. So that means that we would do 60 over 360 and multiply that by the area of the circle, which would be pi times our radius of 4. And we'll square that radius. And if you put that into your calculator, you get about 8.4 units squared for the area of that green sector. Now, the second area of sector problem, we're looking for this blue sector. So now we can use our formula again of 30 being divided by 360 degrees, and that is being multiplied by our whole area of the circle of pi times 6 squared, and that ends up equaling from our calculator about 9.4 rounded to the nearest tenth. And that covers the sector area problem examples. In this third sector area problem, we are starting out with the area of a sector being 432 pi feet squared, and we're trying to look for the length of the radius in feet. So we have to work backwards in this problem. So that means we want to set up our equation first as 432 pi is equal to our sector area formula of 120 degrees being divided by 360 degrees in parentheses, and then being multiplied by our area formula of pi and our unknown radius squared. Now that we have that set up, we want to try to simplify what we have so far. Since we have a fraction over here in the end with just a pi in it and we have a pi on the left side, we can divide out both of those pi symbols and they become ones. And then we can also take this fraction and reduce it to its simplest terms into 1/3 and get rid of that complicated fraction. We want to then rewrite what we have so far, and that means we would have 432 left over on the left side of the equation, and we would have 1/3 r squared on the right side. Now my step here would be to multiply both sides by 3 to get rid of the 1/3 that we have right there. And that means we would have 1296 on the left side, which is 432 times 3, and a r squared remaining on the right side. And then we just have to take the square root of both sides And that means that our answer for our radius ends up being 36 feet, would be the radius of this circle if the sector area or pi slice of AOB is 432 pi feet squared. In number one on these examples, we're moving into using radians in some arc length and sector area problems. In number one, a central angle in a circle is of radius 4 centimeters is 5 pi over 12 radians. Find the length of the intercepted arc in centimeters. So our R is 4 centimeters right here. Our angle right here is 5 pi over 12 radians, which is a little bit less than 90 degrees. And so we can use our formula, the simplified version of it. We know that arc length for radians is equal to just our angle times the radius. We can very easily do 5 pi over 12 times our radius of 4 over 1. And we could simplify this first if we wanted, but we can kind of go right to a calculator since we're looking for it in centimeters and not in terms of pi. So if you were to put this right into your calculator, we would find out that the arc length is about 5.2 centimeters rounded to the nearest tenth of a centimeter. In this sector area example, we have a radius of 6, and this central angle is about pi over 3 radians. So we want to input this into the radians version of our sector area formula, which was pi, our theta over 2, our half of our angle, and then multiply that by r squared. And that gives us the sector area. And we can take our theta of pi over 3. So we're going to take half of pi over 3. And then multiply that answer by r squared, or 6 squared over 1. So we can simplify that a little bit. Half of pi over 3 would be pi over 6, just like how half of 1/3 is 1/6. And then we're going to multiply that by 6 squared. So we can also cross out one of those 6's and cross out this 6, can divide those out and make that into a 1. And so then our answer is going to be equal to 6 pi. And if you check that in a calculator, 6 pi ends up equaling about 18.8 centimeters squared. And that gives us the answer we were looking for in this problem. And that finishes this video on arc length and sector areas using both degrees examples and radians examples.